Thank you all for coming, and thanks for sticking around for the last day. My name's Owen Rubel, and I'll be presenting today on API abstraction and API chaining in Grails. If nobody has ever heard of this, it's a very new concept, and hopefully this will be an enlightening experience for most of you here. So, I want to begin by talking about what an API is, because this is a core concept of what I'm going to be talking about, and a lot of people understand how to build an API, how to access an API, but not a lot of people understand the history of an API, which really builds up on what I'm talking about. So I wanted to talk about what it is, how it works, and what are the architectural pieces and how you build for an API for it to work in the future of your architecture. I mean, a lot of people build APIs in their applications, but the concept of building out for your architecture, for the architectural pieces of proxy and a message queue and an API gateway and Zool and all these other pieces tends to confuse a lot of people. And there's reasons for that. And that's what I'm going to be going into here, and how we can build our APIs, specifically more so in Grails, to alleviate a lot of these problems and make API development a lot easier. So first, what is an API? The acronym for API is Application Programming Interface. And basically what an API is a communication layer for a separation of concern. If we look at the definition, it says, an API specifies a software component in terms of its operation. Therefore, inputs and outputs and underlying types. Its main purpose is to define a set of functionalities that are independent and their respective implementation. So basically, it's an interface to functionality in data, or in other words, a communication layer to a separation of concern. Originally, the intent of an API when we were building applications was a communication that was internalized within an application so that other pieces of the application could talk to it with that functionality and data being separated as a concern. But when we started building out web APIs, that separation of concern didn't make much sense, because we started moving that concern out with the web flow, with the I/O flow to the external architecture, with the proxy and the message queue and things like that. So now we had a separation of concern that became a shared concern in the architecture. And as the system gets more and more advanced, the API needs to share the functionality and data across the architecture. And with the flow, and thus, with the architecture and the flow, and thus cannot have it tied directly to the controllers and the business logic. So naturally, the main purpose isn't just the functionality and the data. The main purpose of an API is communication, the communication to that functionality and to that data. Tying the data and functionality to it initially can be a good concept and can be a good idea, and this is actually a throwback to the way we used to build them. But in modern web APIs, it doesn't make sense, because now we have to abstract that out to shared concerns within our architecture. So it stops making sense at that point. We have a separation of concern that is now a shared concern, and these two things do not mix. They mix like oil and water. So it can't be this way without entanglement and duplication within our architecture. It can either be a shared concern or it can be a separation of concern, but it can't be both. And when we're building our APIs, we're supposed to be building them for now, but build to scale. And we can't build for now as a separation of concern when that separation of concern is eventually going to be a shared concern. That's more like build for now, but build to rip everything apart and rebuild it all over again. So if the API flow is extended out to the architecture, that functionality and data needs to be shared in tooling, and the concern will be duplicated if we don't do so. So, good, excellent. When an API is shared across the call flow, such as in I/O communications, the functionality and data needs to be shared across all tooling, as I've been saying. The API functionality data no longer exists just within the application. It exists across all tooling in the call flow, as you can see here. The request comes in from the request tooling, goes on down to the controller in the application, which does its checks down here, goes back up, goes into the response tooling, and the message queue also has its checks too, but they all have common checks that they do everywhere. Security checks, auth checks, processing, authorization. These are all duplicative things that they're all doing, and they all use the exact same data over and over and over again. So functional and data elements of the API are shared across this flow. And as external tooling shares the API concern, it naturally becomes scattered and entangled. In other words, duplicated and with significant dependencies. And when we look at the API application, there is a lack of separation of concern because we are binding communication logic to the business logic. Business logic is not supposed to handle communication. Its main purpose is to build a resource for an API call. That resource is just supposed to be built there and returned for said call. By binding the logic for handling and processing and data for I/O, we are binding the I/O flow to the controller effectively, thus creating a lack of separation of concern. If this was centralized within the application, like I stated before, we would be fine. But because there is an API flow that goes all the way across the architecture into the application and back out into the architecture, we have a problem with the separation of concern and a shared concern. So this is why I say the API is an architectural cross-cutting concern. Now, for those who are not familiar with aspect-oriented programming, you may not be familiar with the concept of what a cross-cutting concern is. So let's go ahead and go into that real quick. Cross-cutting concern, the definition is, in computer science, a cross-cutting concerns are aspects of a program that affect other concerns. These concerns often cannot be cleanly decomposed, separated from the rest of the system in both design and implementation, and can result in scattering, code duplication, tangling, significant dependency between systems, or both. So when we talk about application concerns, when we talk about applications, concerns are centralized. But when we talk about systems or networks or architecture, concerns like communications or I/O begin to be shared or entangled. Concerns around communication generally share functionality and data common to I/O. So in an architecture, the flow of I/O needs or tends to be able to access these in a common way. But most people only separate the concern within the application. And when the concern extends beyond the application to the architecture, what do we do then? Well, this is a Venn diagram as it exists today with the API being shared. The API is central to the application, and when we need to do anything outside of the architecture, we merely duplicate it. There is no sharing that is going on. And to synchronize this, we have to synchronize all these separate files and all the data therein. This leads to a lot of human error. Ideally, what we want to get to is this, where the API is completely separated as a communication layer within the application, and all that data and functionality can be shared across request tooling and response tooling. And if we send a request to the application, and the application needs to respond back within some sort of loop like batching or API chaining, it can do so, as you see within the Venn diagram here. All it has to do is just send the response back within the application. Say, for instance, we have a batch. And how many here have built a batch? Batch process? Anybody? OK, so you know the first thing that you'll have to do most likely is build a second method to be able to handle that, usually. Well, with this method, if you build it out as a secondary communication layer, you don't have to do that. All you have to do here when the request comes in is detect, is this a linked hash map? Okay, pop it. You pop the data here, go down to the application, handle it, come back up here. Is the linked hash map empty? No. Send it back on over. Pop, come back up, empty, pop, empty, pop, empty, pop. Keep going around until it's empty. And then once it's empty, send it back on out. Thus, everything becomes batchable. You have an internal loop here as a result that can handle all of that data. You can move everything like that up to the communication layer so that you can reference inside your own application without having to send out external requests. You don't ever have to send an external request outside of your application to come back in and reference anything. You can stay within the original request. So, API is shared across the architecture and the application, as we just covered. The API functionality in data is associated with with I/O, not business logic. Duplication of the API functionality across application and architecture. This is what's currently going on. And sharing of the API configuration across the architecture. This is what we want to go towards, but is not currently happening. So what are the issues? Everything's awesome, right? Well, in a sense, everything is working right now, but it's built kind of on top of a Katzenjammer house, where we have this screwed up foundation and everybody just keeps building on top of it. And the tools on top of it may be okay, but we still have a bad foundation, and until we fix that foundation, everything can still collapse in upon itself. So let's take a look at some of those problems. First, we have scattered functionality, and that's not dry. As we already stated, the API functionality is duplicated across all the concerns. Request tooling, response tooling, and the API application. You can move everything out to the request tooling and the response tooling, but because we still have to handle things within the API application, like batching and things like that, where we're going to be sending them back across the communication layer, you still have to do those checks within the application. You still have to handle security. You still have to handle some level of checking upon whether people have access when you send it back around. You want to reduce the number of requests that go outside of your application and back to the proxy or things like that. So you still want to handle things within the application itself, and you can't move everything outside to the request tooling and response tooling, so there's going to be a level of duplication, and unless you find a way to share. There's also duplication as it exists right now within the controller, because you have to do batching, role checking, formatting, in every single method. Every single method has to have these over and over and over and over and over again, instead of just doing them one time up front. If you have these at a communication layer, before you even get to the controller, I could do my security checks, my method checks, and everything at the front door, instead of getting down to the controller. How many people here have been to Costco? Yeah, everybody's been to Costco. So when you go to Costco, what's the first thing that happens? Somebody at the front door comes up to you and they check your ID. And then you're done. You go in and you shop. But you don't go to the bread and somebody rushes up to you and checks your ID again. And you don't go up to the meat and somebody checks your ID again. And you don't go to milk and somebody checks your ID again. Well, this is what's happening. Every single time you go to a method, you're repeating the same service calls or method calls over and over and over again. You have to do the batching again, and you have to do the role checking again. This is redundant. This functionality could be easily removed and moved up, done one time for everything. So it's not dry. It's very, very redundant. Again, If anybody has any questions, please interrupt me. I talk a little fast. Nobody? Okay. This is nice. The role checking is not atomic. It's very entangled and scattered, and this leads to your API docs and options and security being off. And this can be a little hard for some people to understand when I show this slide. So I'm actually going to skip to the other slide, which is a little easier for people to understand. So can everybody see the green? The green in there? Okay, good. So every single system out there, Swagger, Zool, et cetera, checks security on the method externally. Annotations at the top level. And this is how we give them access. We say, can you call it? There, you have access, because I can see that annotation at the top level. But often, we want to be able to say, if role admin calls this, build this a certain way. And if role user calls this, build this another way. Because I don't want them to be able to call it via the ID. I want role user to call it an entirely different other way. And if role admin called it, then I want role admin to get the whole data set and role user to get a partial data set. Now the problem with that is that your API docs are always going to be off 100% of the time, because they can't see this. They can see this, but they can't see this, because they can't get access to this. The same thing with Zool. Zool can't get access to that. You can't pass it. You have no way to pass it. You have no way to drag that out of there. You have to build a way to drag that out of there and pass it. And even if you build a way to drag that out of there and pass it, they still don't know how to read it and how to adapt to it. So the API roles are not atomic either. You have to build a way to say, when I'm making a request, I have request roles, and I have params set with request roles. And when I get back a response, I have response roles, and I have parameters set with response roles as well. So you have to have atomic security for your API as well. But nobody does this. And so as a result, again, API docs, your options, and a lot of your security will be off. So the question is, how come nobody thought of this? Well, there are multiple reasons why nobody's thought of this. I've talked to Amazon, I've talked to Apple, and I get this question every single time that I talk to a large company. And basically what I have come to is that everybody used the old paradigm of API development. When we originally built APIs into applications, we built them so that they could be called internally in the application or internally within the system, but not outside of the architecture. We never planned for a flow to go outside of the application and into the architecture and be used by separate tools or separate systems. That's part of the problem. The other problem is that we always assumed that the controller was the endpoint. Somebody out there said, well, the URI eventually resolves to the endpoint, or the URL eventually resolves to the controller, right? And the controller sends back a resource. Therefore, the controller is the endpoint, right? Well, no, not really. Everybody binds it to the controller now as a result of that thinking, but it isn't really the endpoint. If you look at what an endpoint is in Wikipedia, because, well, we know that Wikipedia is always right, but in this case, it actually is a pretty good definition. What Wikipedia says is, endpoints facilitate a standard programmable layer of abstraction, here's that word again, whereby heterogeneous software systems and or subsystems may communicate with each other, and that the means of communication are decoupled from the communicating subsystems. So in other words, what this is saying is that it is a separate communication layer. The endpoint is a separate communication layer. Even Wikipedia is stating this outright. The endpoint is a separate communication layer. So, what the hell? Where does this put this? Where does this put us? I mean, everybody is doing it wrong then, apparently. But it's really no reason to panic because everything still works. And we do have a path that we can move towards because there is a way to fix this. What we can do is right now, as it exists, everybody is doing this, where we have, now excuse me if I just use a proxy in a message queue because I'm not going to put in all tooling, but what everybody's doing is that they're using a API gate. The request comes in, hits the controller, does data checks, security checks, processing, makes a call to the model sends it back to the controller, and the controller sends the response out to, response tooling. Whereas the controller on the other side does processing and response formatting. But when you consider a communication layer as, for instance, a pre-handler and a post-handler, in Grails, we call this filters. Filters extend off of the handler interceptor in Spring. Now, we can use a filter, and I can show, I'm just going to show this real quick. Let's escape this and go on in. As long as nobody's surfing. Here we go. So what we can do is we can use a API toolkit filter, and we can intercept. Is it still showing? Why did this stop showing? Can I mirror this? Maybe I can just pull up my desktop. Oh, hold on. I'll do this. OK, fine. It wants to be a pain in the butt. I'll just do it like this. There we go. I'll go on over here. Trying my best. I can't even see what I'm doing here. Wants to bring it up over here is the problem. Stupid Apple. Hates Linux. OK, close enough. What's that?
It smells too much like freedom.
Indeed. Oh, there we go. And we will scroll on down. There we go. And I just will go like this. So what we can do, I'm just going to surf this backwards, is, I don't know how well you can see this, is in the filters, we create a custom filter and we add in the entry point right here for all the APIs. And then in the before filter, we add in all of our checks, and the after filter, add in all of our checks for that too as well. And then we do all of our redirects and all of our handling for batches, chaining, et cetera, and poof, we're done. It's a little harder than that, but that's pretty much it. Oh, I'll go now. And let's go on back. But there we go. The pre-handler and the post-handler will act as the endpoint to handle all the checks, all the security, all of the configurations, everything that you need to do before going to the controller. So effectively, all your controller has to do is build a resource. Nothing else. No security, no configuration, no checking, nothing. It just builds a resource. And then it hands it on back to the post controller, where it'll say, was this a batch? Was this a chain? Okay, let's continue on. Let's build another resource, or let's do some more. You don't have to. Literally, your API development comes down to building your controllers. That's about it. Well, there's a little more to it than that. You actually have to build your controllers and an API to object for every single controller, telling it how to build a controller. So I keep talking about how we need to share that data amongst your request tooling and your response tooling. Well, there's something that I call an API object. And this API object is a one-for-one mapping to each one of your controllers, which tells it all of the variables. It's basically like a domain, but it's built in JSON, which tells it all of the variables that will be used, their basic definitions, versioning, and how they will be used. So up here, we have the values, the ID, the type of data that they are, test data, basic definition. Current stable is the current stable version, because you can have multiple versions. This is a reloadable object, by the way, because this separates form from function. This has nothing to do with the resource. The resources and how they are built, we don't touch it. This has everything to do with the request, how the client requests the data, and how we're sending it back. It does not change the application. It has nothing to do with how the application builds the data. This is just how the client requests the data. So, deprecation, you can set a deprecation date on every single version. Default, this is the default action. So in your controllers, you know that you have a default action. You can set a default action here too. If nobody sets an action, or if they don't have a URI but they call something, that will set the default action, because this is Test.json. So if they call test and they don't call anything else, that will pop and it'll go to here. And then everything that's associated, all the URIs that are in here that they can call. Test show, what kind of method it is. Description, this will show in your API docs. And the roles. So the annotation that showed at the top of your method, that's that right there. And you can have roles on your request, as I was showing before, and your response. This basically says everybody can request this via the ID, and everybody will get back ID, but only role admin will get back test data. So you can determine what kind of data you can request by, whose role can request that data, and who gets back said data. Even beyond that, I can say, you can't request this data. Nobody can have access to this data. But you can return data from this. What possible use could this have? Well, by not passing an ID to this, This means that the only way you can access this is through a chained response, or through a chained method, meaning that I have to call another method, pass data from that to this, and I'm going to go into API chaining in a little bit, in order to get this. You would never see the ID, you would never see the data, the only thing you can see is this. And then there's a varied role request that I keep talking about. Upon request, role admin can request it via ID, role user can request it via username. On response, role admin gets back ID, everybody gets back this. So role admin gets back ID, username, fname, lname, but everybody else just gets back that. So this allows for much more atomic requests and response, and believe it or not, this all shows up within your options and API docs and everything. This separates our package from our packaging. So we can now version the application, and we can version the API. Previously, we can't version the API. We were only versioning the packaging. Though people called it versioning the API, what you were doing is you were versioning the API application. It was all bundled together. It would be like bundling the API and or bundling the Twinkie and the Twinkie wrapper all at the same time. Can you imagine a factory that would just squirt out the Twinkie and the wrapper at the same time and say, there you go? No, you have to squirt out the Twinkie and then have another process build the wrapper. Now, here, what we've done is that we have one process that squirts out the Twinkie and another process that builds the wrapper. Because the one thing that doesn't change on a regular basis is the Twinkie. The Twinkie never changes, but the wrapper changes constantly. Marketing comes down and says, hey, I need this, and sales comes over and says, hey, I need that, and I want to change that. I want to change that role. I want to change the way this data comes in. I want to change that. The packaging constantly changes, but the Twinkie doesn't. Resource does not change often, but the way it is requested will, as I just mentioned. The data needs to be separated and shared concern. So this is something we already covered. So how does this all fit together? I've been talking about everything else but how we build this out. So this has been built as a API plugin in Grails. It's called the API Toolkit, and it's currently functioning and working. But the important thing is, how does it work? So let's go into that. We talked about API objects. We talked about how they're shared. We talked about the API flow. So how does it all work together? Well, what we effectively do is that the API objects are all loaded at runtime and shared in a common cache so that any tools can read these, the application can read these, and they all share the same methods across the entire architecture, application, instances, et cetera, et cetera. So everybody is syncing and sharing the exact same data. No data is different. It's the exact same data. It's the exact same API object. So when Zool gets a call in, or your proxy or whatever, it will look at that URI and see all of the security, all of the rules, how it's going to be requested, et cetera, and it can reject right here, which frees up more requests, which frees up more processing, and doesn't even have to go on down to the application. It doesn't have to go down to your instances. If it does get down to your application, say for instance it's a chain, what will happen is it can make one call to an API that Zool already okayed, but say for instance the next API call in the chain you didn't check. Well, we can check right here, and it can reject all over again. Same thing at the message queue. It's all the exact same data, the exact same checks. There's no chance of it getting out of sync. And you can reload on the fly. Anytime you get a change, anytime you get new rules, anytime you get new data, reload it in the cache. They'll all have the exact same access, and they'll be reading the exact same object. Any questions? And one of the other advantages of this is if any of you have been doing API sharding off of data, you can also now do API functional sharding. So while you've been, say for instance, you say, I want to have a separate server for the store, a separate server for the users, et cetera, et cetera. Now you can say, I can have a separate server for the store, a separate server for store batching, a separate server for store chaining, a separate server for user batching, a separate server for user chaining, so on and so forth. So you don't have, if you have a ton of batching going on, you can separate that out to a functional server so that all your batching for users is separated out by process on a separate server. Not just by data, but separating out by process as well now. So the benefits of this are all easier abstraction. It's to external architecture. The logic checks are centralized and done early. We can check incoming and outgoing data based upon the role. Your get, put, post, delete can handle cache and same resource. Your caching is simplified as a result of that. Your API docs and options are accurate now. You can have a cached version of the API config. The API objects are relatable, which allows us to do chaining. Once you have your API objects in your cache, you can relate one API object to the next, which allows for chaining, which I'm going to get into in a second. And this enables common redirection back to the COM layer, which I showed, without having to do a second request and go outside of your original request. So if I can do a demo here without getting a black screen. Yay. This is going to be difficult. Oh. There we go. Damn it. Oh, there we go. Now it doesn't want to recognize my keyboard. All right. I'm just going to restart this. Okay, so you can see that a bit. Good. Excellent. Okay. There. There we go. Oh, damn. That's right. I got to shut down Jenkins. There we go. Okay, part 1. I'm not going to type this all out because I'm running slow on time. I figured I would. So this is just to get us logged in. And let's do an options call real quick. Just to show how options will work. Hard to view sideways. OK, so you can see just calling options on that. This is how options will work. And this is basically how the API docs will build off of. It gives a full output from the options just by calling the data there. And literally, your API docs would build directly off of this. Let's go ahead and keep going. This is really nothing spectacular. Get, really simple stuff. But now let's move on to the cool stuff. Do a quick batch. So this is a batch where we're going to save everything here. Boom. And it outputs the very last one. But we could have probably output everything. If we list them out. Here's the entire list of everything in there. Posts that they're related to, et cetera, et cetera. And let's just go ahead and delete. Do I have that filled in? I don't think I do. Well, I'm not going to do delete because I got to keep moving. But you get the idea. And all of this, the batching and everything, we don't have to go back out. We don't have to come back in. It's just all handled within the communication layer. So I accidentally deleted that. Let's keep going. So what is API chaining? API chaining is effectively the ability to call one API, and this is all done from the client side. This isn't done on the server side. It's the ability to call one API, for the client to call one API, get the data back, and send a key or some sort of referential key from that data set to the next API call, get that data back, send a referential key to the next call, et cetera, et cetera, et cetera, et cetera, et cetera, et cetera, until they finally get data back. You can only use one unsafe method because it's one request. So obviously, with one request, you're only going to be sending either a get, put, post, or delete. So you're only sending one method. So you can only have one unsafe method. And as a result of having one unsafe method, you can only send data for one unsafe method. And as a result of having one unsafe method, you can only have it at the beginning of the chain or at the end of the chain because they signify either a beginning or an end. You can't have it someplace in the middle because that confuses things. Potentially, if you were to have it someplace in the middle, there is the capability to put another unsafe method in there. Oh, I'm sorry. I did not start this up. So there are three types of API chains. There's a post chain, a pre-chain, and a blank chain, basically what I just covered. And these are just a basic run-through of them where you can go get, put, post, get, or get. And this is This is not limited to 4. You can do 10, you can do 15, you can do 25. The limitation is up to you. I would normally put it at about 5 because if you get a lot of mobile people hitting this and trying to do 25 chains in a row, you're going to get bogged down. But this is a big benefit for mobile developers and what. Let's see. So how to send an API chain? First, you have to define the method. You have to define the content type and the initial URL that you are calling, because everything else chains off of this initial URL. Then, down in the chain, you define the type of chain that it's going to be and the order of the chain that they're going to come off of. So the first chain, the initial chain in this, is person show, which is then going to, whoops, let's fix that. I want to fix this real quick. You also have to do one additional thing. Let's see here. Okay. All right. Fix that. You also have to pass the referential key, the initial referential key from the beginning chain. So the beginning chain passes an initial referential key of department ID for department show. Then department show sends its referential key of company ID to company update. Company update is the last one in this, and then it hits return. Pretty simple. The call flow for this is not as simple. And I just added this to the slide so that everybody here who wants to know how the call flow works, these slides will eventually be available online. So when you get these slides online, take a good long look at the call flow, and there it is. But I don't want to spend too much time on this. But I'm adding this to the slides so that anybody who wants to spend some time on this, take a look at it. This is also available on the API Toolkit documentation. So if you go to the API Toolkit documentation, go ahead and take a look at this. Everything is freely available, so you can duplicate this. Another nice thing about API chaining is that you can do API chaining branching. So at any point in the chain, if you want, you can just return right in the middle and just branch off of the data that you got right there in the middle and restart the chain. So I can go get return, branch off of that data right there, start a new chain, and then start back up my chain again. So what are the benefits of API chaining? You can reduce your request response throughput by up to 50%. This is fantastic for mobile devices where they have horrible throughput and they just have to go request, get the data, request, get the data. This is also really good for servers because if you have a lot of mobile devices and things like that that are doing that, this will cut down your number of calls and the amount of throughput. It uses dynamic relationships rather than URL mapping, like things with Helios, where they add links. The less you have to do through links and the more you can do through relationships, the better. You can secure and block the showing of IDs through your relationships. For those who are concerned with showing your IDs, you don't have to show your IDs if you don't want through this. Everything can be just handled through API chains. Only the initial ID has to be known. Or if you don't want to show the initial ID, you can do that through a index. It also reduces the coding required. There's no URL mapping required for this. So let's get to this demo as well. I think I'm running a little over. Am I running a little over? Does anybody know?
You're till 2:30, you're fine.
Till 2:30? Oh, okay, well then. I'm a little slow. I'm going a little fast. Damn it.
All is well. Breathe.
Okay, so let's see here. I did it again. Hope the keyboard works. Good. All right. Well, if anything, I can get you guys into the groovy and Android talk a little early. All right. So let's go ahead and get into here. So first, I'm going to demo a blank chain. Let's get my security back up and rolling. Make sure that's in there. Yes. Okay. So first things first, a blank chain. So a blank chain is literally just a chain of gets from one to another to another to another to get information. As you can see, bam, piece of cake. Comes back really quick. Where is my cursor? There is my cursor. A second, a pre-chain. Pre-chain has the unsafe method in the front. What we're going to do here is a save. And what we're doing is that we're saving a post, and then we are going to pull up the section ID, and then we're going to list all the posts by the section. Apologize for this. I can't see very well from this angle. So let's give that a shot. Bam, there you go. That's all the posts in the section. I probably should have populated this database a little better. And this last one is a post chain where we are going to edit the section. Through a chain. Well, that did not seem to work. Well, there seems to be a bit of a problem in that. But I'll have to take a look at that. Maybe it's a problem with the edit. But you get the idea. So if you have any questions, you can go ahead and take a look at the GitHub docs on GitHub for the Grails API Toolkit. There are videos online on YouTube. Here's the link for that. The Grails project is the Grails API Toolkit. And what's that?
Get on that.
Ah, jeez, thank you very much. There we go. That's better. So the GitHub docs are Grails API Toolkit docs. YouTube channel has a couple videos up on that. I'll be updating that regularly. The Grails project, this is probably going to be having a lot more added to it recently with Spring Boot. Probably going to be forking a lot of this in the coming days. And the company site is nosegrind.net. I also added my Twitter on the front page. Let's see. Right there. So if anybody needs to contact me. Oh, I did not. Well, if anybody needs to contact me, it's pretty easy. It's Owen Rubel on Twitter. Any questions?
So just to kind of get it, like a lot of the stuff you had up there was like abstract, like generic, like post, put, get. Is the intent that you would have API consumers, they hit your API and say, I'm going to do this, and I'm also then next going to call this, and then call this, but do it all in one shot, in one request, or?
Yeah, they do it all in one request. It all takes place in one request, but they can only use one unsafe method. So since it's one request, they can only send one method, be it be get, put, post, or delete. So that one unsafe method has to be at the beginning or at the end of the chain.
Got it.
But yeah, it helps a lot in making it so that people can send multiple requests at the exact same time without having to go back out and call with another request. Yeah. Yes?
Can you define what you mean by an unsafe method?
An unsafe method, not get. But basically, something that's, when I say unsafe, I mean idempotent and unsafe. Yeah.
Is there any live examples of projects which use this API chain?
No, because I really don't keep track of that.
Popular sites that are already using this API chain concept?
I kind of want to keep track of it, but I kind of don't because I feel I'm very against tracking. And I don't want people to not use it because it is being tracked. I've talked to people that I've helped implement it, yeah, so I've talked to people that I've helped implement it, but I don't know how far along they are.
Sorry.
No.
Can you talk a little bit more about like how these like API doc generation tools like Swagger and things like that can consume this? Is that something that's been built, or is that like a possibility?
Yep. So I was at a meetup ever so recently, and I talked to the CEO of Swagger. And I mentioned this to him that the tools don't do this, and they have a lack of ability to do this. This was a meetup with Apiary and Apigee and Swagger, and they are very unaware that there is a need for this. They are very unaware that a separation of concern and a cross-cutting concern are not compatible. Some people actually even said, oh, I disagree, they're completely compatible. At which point, I just had to bite my tongue. Yeah, I think specifically with Swagger, he was the best in saying, oh, I had no idea that we couldn't do that. And I said, yeah, well, nobody can do that because until developers start implementing it so that there is shared functionality and data across the architecture, you'll never be able to do that. Because until there's something like an API object that can be shared, then they can do that. You have to have that API object, all the data and everything separated into an API object so that it can be shared.
Is that something that, I mean, you had an implementation there, is that some sort of like proposed spec, or is that just something of your own creation?
Yeah, it's kind of a proposed spec. I'd like it to be a proposed spec, and I'd like industry people to start jumping on board and expanding it wherever they want or see need. But I spent about a year on this, working with different tools and different vendors and seeing what their needs were and everything, and expanding it out bit by bit. And as I worked with more tools and more vendors and what, I saw As is, this can work with a variety of different tools and different vendors and with your proxy and message queue and everything. It just requires them to be able to find a way to integrate with scripting and what. It can be read into Grails easily. It can be read into Spring easily. There's really no problem integrating whatsoever. It's just raw data. It works great. It's really blazingly fast. I mean, if you do A/B benchmark, Apache Bench, if you test it with Apache Bench on just like your laptop with 50 concurrency and 10,000 requests, you'll find it will get down to 0.1 or 0.100 or 0.197 per request. It's and that's milliseconds. It's amazingly fast, and you can even get a lot better than that. When I moved to Spring Boot or Grails 3.0, I expect it to be 10 times faster than that because I'm going to remove 1,000,000 times more cruft. So, any other questions? Yeah.
I don't want to sound stupid, but
There are no stupid questions.
we'll see about that. But with these chains of requests, because it was kind of confusing me there because the client only makes one request.
Yes.
Okay, and then apparently something server side, some agent server side turns around and makes all these.
Here, we're going back. Piece of cake. So basically what happens is that, let's see if I can pull this up. Nope. Go back. Okay, so what happens is that the request comes in, and it can go through tooling, and tooling can handle the security here or whatever. We'll ignore that because that has nothing to do with your question. But we'll say the request can come into here. Now, since we're talking about API chaining, the first chain gets handled here in the pre-handler. And since we're talking about Grails, we'll talk about it as filters. So this is the before filter. And the before filter does all the checks, does all the security, and goes, okay, I see this URI, let's go ahead and handle it. And it sends it on down to the controller, comes on down to the model, comes back up to the controller. Then we get to the after filter. The after filter goes, this is a chain. I see that we got data back from it. I see that it's that we were supposed to pass this other data, and I see that there's a second part to this chain. There's a next link in this chain. Does everything look right? Does everything pass all right? And it goes, okay, yeah, sure, everything looks right. Let's go ahead and do it. And rather than going all the way out and coming back in, it just goes right here. Boink. There's no external request. It's a communication layer. Right here is effectively a communication layer.
So it's internal to the server.
It's in the application. It's not the server, it's the application. It's the handler interceptors. So it doesn't have to go anyplace. You can't do that in the controller. In the controller, you have to go out and come back in. But by separating that as a communication layer at the front controller, see the front controller in Grails known as the servlet, Grails servlet? Yeah, in Grails it's known as the Grails servlet. But in MVC development, everything's wrapped in a front controller. And MVC is packaged in the front controller. And the front controller handles all the request and response before it gets down to the controller. So naturally, the natural place to put the I/O is in the front controller. So if you want to have a separate communication layer, all you have to do is just separate it out of the controller and just stick it on up into the front controller. Yeah. And then once you have it up in the front controller, it's far easier to move it out to other pieces, because that's effectively the exterior layer. Whoa. Everybody got that on film? So yeah, it saves from having to do external requests. It keeps things internal. It's just a far better methodology, I think.
So depending on how you construct your chain, you can get then different responses back, right? So you may be making an initial call to like the show controller, but because of how you chained it, you may get something else back every time. Is that
The
correct?
show controller.
Well, like,
Or you
you're,
mean-
like you know, where you're delegating to
Like-
like show the section one.
Person show.
Right.
Yeah.
And so, depending on how the client sends up and formulates the chain, you can get.
Yeah,
basically
whatever the
same
end of it
request,
is.
Where it's at the same endpoint, you can get different responses.
Yeah, whatever the end of the chain is,
That's what you get.
that's what you get. Yeah, but there's a piece in the chain that allows you to, there's a variable, a Boolean, that allows you to collect. So if you want to collect the results, you can too as well, because some people may want to collect everything in the chain. I don't find it useful, but I realized at some point somebody might want to do that, because they're going through all of these classic example, a get chain, or what I call a blank chain. You have all these gets that you're doing, one after another, that you're chaining through. You may want to get all the data back from every single one and collect it in a linked hash map and send it on back, or a JSON map, send it on back, which would be very, very useful, because then you don't have to call back in and get that data all over. So yeah, it's whatever you can do to make it more efficient, make it easier on the clients, especially because we're moving towards a mobile world. And in a mobile world, there's not much throughput for mobile devices right now. And so if they can make one request and get all of their work done in that single request, why not? But this also works for more robust clients too as well. And another great thing with this that I probably didn't mention is that since the formatting, since we're removing the formatting, and the formatting is done in the after state up here and not in the controller methods all send back the exact same method. So your get method, your put method, your post method, your delete method for your person class will all send back a person domain object. So they don't send back a different object. You don't have to format. You don't have to change the object there. Because as you saw in the, let's see where it is. As you saw in the API object, we tell it how to format. We say how to format right here. And this is all handled at the API layer. When it sends back that object, it says, okay, we got the object back, now let's format it. So since we're formatting at the API layer, everything in the controller, all those resources, can all be cached the same. It's one object that is cached the same, as long as you're sending back the same object through all your methods. As long as the concern is identical, you can cache the same way for all of your objects.
When you do some sort of versioning, let's say you need to you rename like a property on your domain class or whatever.
Yeah.
You do some sort of transformation in here if you have like version 1 and it's like name versus first name.
Oh, for your controller?
Well, it's like you're like you're returning out a person, and a person has a property called like name on it, and later on down the road you need to change your domain controller to be first name to match some sort of for whatever reason. That's kind of a contrived example, but can you define like in the versions in the API object that name is now first name, so you can translate it?
Well, that's versioning within the application.
Okay.
Because you've changed how the application now sends back data, not how the API is requesting data.
Okay.
So Yes, you can change the versioning in the application.
That'd be handled outside of this.
Yes, outside of this, that would be handled within the application. That's another tricky thing that I have a hard time explaining to people, that I'm introducing a new way of versioning that is versioning the way people request the data versus versioning the way the application builds the data, which is a tricky thing to grasp now as well. All of this, everything that I'm presenting is very, very tricky, and some people only grasp like small little elements of it, and I totally understand, but it's all very new, it's all very bleeding edge, and you guys are some of the first. Any other questions? Nope? No? Sure? All right, I'm going to cut you loose. It's been a pleasure.